Hello everyone, we're gonna learn section 3.3 today, arc length and curvature. So curvature, I wrote, made a note here, measure how sharply a curve will turn. So we're gonna talk about this later. So arc length, we talked in the previous class, right? So arc length, from trigonometry. So we have the symbol we are using as, right? So r times the theta. So r is radius and theta is in radians, right? And from calculus 2, we have arc length. How to find arc length? So we have integration and then square root of 1 plus f prime of x squared dx. Now, what about the calculus 3? So we have a formula for arc length. So two-dimension plane curve. Then this is a vector valued function, right? So we did a 3.2 section. So we do derivative and we do integrate the vector valued function. So we talk about the arc length, about the vector valued function in calculus 3, okay? Then we are using same symbol as, so arc length S. We have integration, then square root of f prime of t squared plus g prime of t squared dt, right? What is that? We have a square root of this, and this is magnitude of r prime over t dt, right? Okay, so same as three-dimension space curve. So we have integral of definite integration from a to b. We want to know about the arc length. Then square root of f prime over t squared plus g prime over t squared plus h prime over t squared dt. So this is the magnitude of r prime over t. Yeah. Okay, let's do example. So we have calculate the arc length of, that is a two-dimension, right? So let's talk about, this is f over t. This is g over t. Okay, so f over t equal to 3t minus 2. Then f prime over t, what do you get? It's a 3. Good. G over t, which is 4t plus 5. What's the g prime over t? It's just a 4. So arc length. So plane. So let's using this one. Copy. Paste. Okay. So we have from 1 to 5. We want to know about the arc length from 1 to 5. And then square root of f prime of t squared, which is 3 squared, plus g prime of t squared, which is 4 squared dt, right? Okay, so 3 squared plus 4 squared, which is square root of 25, which is 5. Very straightforward, right? So that would be 5t from definite integration. So from 1 to 5, which is 5, we can do that. Minus 1, right? Which is 20, yeah. Okay, how about this? So we have, this is 8. Okay, B. So we have R over T equal to 3 cosine negative 5t and 4 cosine negative 5t and 5 sine negative 5t. Yeah. So we can express this as f g h o t from between 0 to pi. Okay. So we have f over t, which is 3 cosine negative 5t. Then f prime over t. So we keep the coefficient 3, right? And then what's the derivative of cosine, which is negative sine, right? And then chain rule times negative 5, right? So negative sine negative 5t times negative 5, right? So that will be negative negative is positive, positive sine, positive 15 sine negative 5t, right? Okay, how about g of t, which is 4 cosine negative 5t, g prime of t, same reason, so we can just do directly 4 times negative 5, which is negative 20 and negative, so no, it's the same thing, positive, right? So we have a positive 20 sine negative 5t, right? How about h over t? We have a 5 sine negative 5t. So h prime of t, we have a 5. What's the derivative of a sine? It's a cosine negative 5t, and then chain rule negative 5, right? So we get negative 25 cosine negative 5t. Yeah. Okay. The formula we have this. Copy. A lot of work on. Okay. So from 0 to pi, definite integration. So there will be 0 to pi square root of f prime of t. So we have a 15 sine negative 5t squared plus g of t, g prime of t, 20 sine negative 5t squared and plus negative 25 cosine negative 5t. Yeah. And then square them. Yeah. Okay. So you do calculate. So 15 squared, what do you get? 225? So that will be 0 to pi 225 sine square negative 5t. Yeah, we express this way. And 20 squared, we get 400. And then sine squared negative 5t. And 25 squared, then we have 625 cosine squared negative 5t dt. Yeah. Okay. Let's combine like term. So we have, this is like term, right? So 225 plus 400, which is 625 sine squared, negative 5t. Then we have this, yeah? So there will be 0 to pi 625 sine squared negative 5t plus 605. Ooh, nice number, right? Cosine squared negative 5t dt. Yeah, what is this? Yeah, so lucky. So there will be 625 sine squared negative 5t plus cosine squared negative 5t, right? dt. This is 1, right? So this is 1. Note cosine square x plus sine square x equal to 1, right? Okay, so then we have just 625, right? So 625 dt, 625 square root of 625, which is 25. Then integrate 25t from 0 to pi. So we get 25 pi over 0, which is 25 pi. Very good. Okay, so we have another terminology, which is arc length parameterization. Okay, so let's do it. Okay, so we have arc length parameterization. Okay, so basically this means we will have parameter, right? So parameter. So normally we are using T, right? So we will change it to S at the end. That is arc length parameterization. Okay, so we have the formula here, arc length function, and this is the formula. Okay, all right. So we will use this one later for curvature and then later sections. Okay, so we have find arc length parameter uh, pronunciation parameterization, right? I was good earlier. And then we have r over t for cosine t I have plus for sine t j hat. So this is f, this is z. So we have a magnitude of RU, right? So that means we can just treat t as u. So let's say that f of u, how about that? Then for cosine u, then f of prime of u, which is for negative sine u, right? And we have g of u, which is for sine u. Then g prime of u, which is for cosine u, right? Okay, so we have the formula, copy that. So that will be A. So A in the case is 0. And we keep using T. And then magnitude of R prime of U, that is square root of -4 sine U squared, right? And plus 4 cosine U squared du. Yeah. Okay, then there will be from 0 to T, and that will be 16 sine square U plus 16 cosine square U du. Okay, we had the experience earlier, right? So that will be just a 16. So we have from 0 to T, square root of 16 du, which is 4 du, right? Okay, then there will be, we can use for u from 0 to t, right? So that will be 4t. Okay, so we are going to make a parameterization. So look, let's set s equal to 4t. Let me using s like that, right? Okay, then solve for t. That will be t equal to s over 4 then. Yeah. Okay, now we have r over t. We change it to other parameter, which is t, right? That's it. So let me use this one. Copy. And then we will use that r of t, which is s over 4. Yeah. Okay, so that is 4 cosine s over 4. I had plus 4 sine t, t equal to s over 4. J hat. So we have t is greater than or equal to 0. So thus s is greater than or equal to 0. S is greater equal to 0. Is it good? So this is, we say that arc length parameterization, right? Okay, so here is the second problem. So we have r of t, t plus 3, 2t minus 4, 2t, t is greater than or equal to 3. So we want to make a parameterization. So we have the formula. So s over t, equal to t star to 3 to the greater, so 3 to t. And, ooh, let's make this one first. So let's say that f of u, this is f, g, h, right? So t plus 3, f prime of u, which is 1. Oh, not t, 1. I'm sorry, u. 1. And g of u, which is 2u minus 4. So g prime of u, which is 2. And h of u, which is 2u. So h prime of u, which is 2. Yeah. Okay. So we have square root of 1 squared plus 2 squared plus 2 squared, right? And du. So we have square root of 9. That is 3, right? Okay, then there is a 3u from evaluate 3 to t. So 3t minus 3, which is 3t minus 9, right? Okay, so we have s of t. Just to make a s, yeah? Skip the one step. So 3t minus 9. Now, we need to solve for t, right? So solve for t. So that will be s plus 9 equal to 3t. So t equal to s over 3 plus 9 over 3. What do you get? 9 over 3. Okay, let me do this one first then. So s plus 9 over 3, that is s over 3 plus 3, yeah? Okay, we have a restriction about the t. T must be greater than or equal to 3, right? In the beginning. Okay. We have restriction, right? T is greater than or equal to 3. So look, we have t equal to s over 3 plus 3, right? So we substitute 3 equal to here, right? So 3 equal to s over 3 plus 3. Now, solve for 3. I'm sorry for 3. Solve for s. Crazy. Because solve for t, solve for t. I mean, solve for t, solve for s. Yeah. Why we are doing this? Because we want to know about the restriction about the s too. Okay. So let's do s. Solve for s. So 3 minus 3, which is 0. S over 3. So s equal to 0 then. Yeah. Okay. So we say that s is greater than or equal to 0 when t is greater than or equal to 3, s is greater than or equal to 0. Make sense? Okay. So we had this problem from the beginning, right? Copy. Then r of t, which is r of s over 3 plus 3, right? So r of s over 3 plus 3 equal to t. So S plus 3, I'm sorry, S over 3 plus 3 plus 3, right? Plus 3. And then 2 S over 3 plus 3 minus 4. And I need a space. And 2t. 2 S over 3 plus 3, yeah? Okay, a little bit. Let's break work. So we will get S over 3 plus 6. And then we do distribute. So 2S over 3 plus 6 minus 4, which is plus 2, right? And then there will be 2S over 3 plus 6, yes? And then this S must be greater than or equal to 0. So we call this is arc length parameterization. Zation. Last one. Okay. So we're gonna do curvature. Okay, so we have a curvature. So curvature means to measure how sharply smooth curve turns. So let me show you this picture. So we have like arc length, right? So we have the curve. Then think about your driving. So which one is more sharply to stay on the road, right? So this is more smooth and this is more sharp, right? So we have a circle has a constant curvature, just circle itself, right? And then the curvature of a circle is equal to reciprocal of its radius. Then we can express, let's make a curvature, like it sounds like curvature, K, right? So they're using K equal to 1 over R then, right? So we have a smaller radius of a circle, then greater curvature. That is what I talked about earlier, right? So this one is smaller, so smaller radius of a circle is greater curvature, right? So think about R equal to 2, then curvature will be 1/2, right? If we have R equal to 10, about 100, yeah? Then 1 over 100, right? 1 over 100, yeah? So this one is more bigger, right? Yeah. The smaller radius of a circle is greater curvature, right? How sharply, yeah? More sharp, yeah? Means more sharp. Okay, all right. So what happened to curvature equal to 0, right? That means there is no curve, yeah? Okay, that means a straight line, right? So straight line. Okay, now, oh, I should have, oh, let me erase it first. You cannot see that, right? Okay, where is the greatest curvature in the case? Yeah. So think about you driving. So number one, number two, number three. Number two, right? So think more sharp or more smaller radius. Yeah. So answer is number two. Make sense? Okay, then we have the formula of curvature. How do you find the curvature, right? So if we have a circle, it's easily to find because 1/r, right? Okay. Okay, so we have three different curvature formulas. So let's do that. We have an example. So find the curvature of out of t equal to 4 cosine t I for sine t and 3tk. So we want to know about the curvature at when t equal to 4 pi over 3, right? So for your reference, maybe we can note, right? So note r of 4 pi over 3, then for cosine 4 pi over 3, I have plus 4 sine 4 pi over 3, j hat plus 3 4 pi over 3, k hat, right? So that will be 4 cosine 4 pi over 3, we get negative 1/2 I had plus 4 sine 4 pi over 3, which is negative square root of 3 over 2 j hat, and that will be 4 pi k, right? So let's just simplify. So we get negative 2i minus 2 square root over 3j plus 4 pi k. Yeah. So approximately, that scale looks like this is 4, right? So negative 2i, so it's half, negative 2i, and negative 2 square root of 3, negative 2 square root of 3, approximately 3.46, 4 pi approximately 12.57. Okay, so negative 2i and then negative 3.46. So negative 3 points. So this is a 3 point here. And then we make a positive, and then almost a 13, right? So just say approximately about here. Uh, approximately, yeah. So R of 4 pi over 3. So we want to know about the curvature at the point, yeah? Okay, so let's using this one first, and then we try every formula, how to apply, right? So we have this one. Come on, please. Hey, come on. Okay, good boy. Good girl. Okay, so we have, oh, yeah. Let's see using that. So we have a curvature formula, magnitude of the unit tangent vector of prime, right? So what is the unit tangent vector? R prime of t over magnitude of R prime of t. Yeah. Then this one we can easily to find from there, right? Okay. So let's see. Let's bring this one more time. Mm, okay. Oh, let me pause and then let me click. Okay, so let's find out unit tangent vector first. So R prime of t, I don't have to write down, right? So we have there. So we have a 4 negative 4 sine t I and positive 4 cosine t j plus 3k, right? Over square root negative 4 sine t squared plus 4 cosine t squared plus 3 squared, right? Okay, so that will be, let's calculate. We had experienced the sine squared t and cosine squared t, right? So that will be just us thinking 16 then, right? Just 16. Yeah. 16 sine squared t plus cosine squared t. So we knew this is 1, right? And then that's 9, right? So which is 25. So there will be negative 4 sine t I hat plus 4 cosine t j hat plus 3k hat. And the denominator has 5. Well, so we get 16 plus 9, 25, which is 5. Yeah. Okay, so we want to have a magnitude of that, right? So magnitude of this and divided by that. Okay, so curvature, copy, note, 16 plus 9. Yeah. Okay. Magnitude of that. Oh, derivative first. Okay. So look, I want to express this one. Ah, How about we take out the factor of 1 over 5? Yeah, so negative 4 sine t I hat plus 4 cosine t j hat plus 3 k hat, right? Okay, now then derivative and then squared magnitude. So keep the coefficient. So negative 4 over 5. Derivative of sine, which is cosine, and then squared, plus 4 over 5, negative sine, and then that's it, right? 3 is 0 over magnitude of, where is it? Magnitude of r prime of t. Oh, there is, yeah. So that's the 5, yeah. Okay. So numerator we get we have square root of 4, 5 square down and cosine squared plus sine squared over 5, which is 4 over 5 over 5. Yeah. So that would be 1 over 5. Yeah. Which is 4 over 25. Approximately 0.16. You cannot see? Yeah. Is it okay? All right. So let's see using another formula. So number 2. Copy. Using other formula. Okay, so cross product. So we have to have the first and the magnitude, right? Okay, so we need the r prime of t, which is, oh, that's magnitude. R prime of t, we have r prime of t. How about that? Let's just, oh, let's do this one. Copy. And then we have r prime of t, and then r second prime of t, then negative 4 cosine t minus 4 sine t 0, right? Okay, cross product equal to I, J, K, negative 4 sine t 4 cosine t 3, negative 4 cosine t, negative 4 sine t 0. Okay. So I, J, K, right? So I, 4 cosine t 3, negative 4 sine t 0. And then J, negative 4 sine t, negative 4 cosine t, J 3, 0, K. Negative 4 sine t, 4 cosine t, negative 4 cosine t, negative 4 sine t. So multiply 0 minus plus 12 sine t. I had, good thing we have 0. 0 minus plus 12 cosine t, j hat. And the last one plus 16 sine square t minus plus 16 cosine square t k hat, right? All right, so we get 12 sine t I hat minus 12 cosine t j hat. So we have a 16 then, yeah, plus 16. Because we have sine square t, cosine square t, right? Okay, now J, K, sorry, K hat. That's the cross product. Okay, now we have to do magnitude. So magnitude of R prime over T cross product of R second prime. So magnitude, so 12 sine T squared plus negative 12 cosine T squared plus 16 squared. Okay, so that will be 12 squared and sine squared t plus cosine squared t plus 16 squared. So this is 1. Can you please calculate 12 squared plus 16 squared? Square root of 400, which is 20. Yeah. Okay. So that's the numerator. Denominator are prime over t. So we had 5 earlier, right? So let me calculate. Copy. Curvature. So we have 20 over 5 to the third power. Simplify. Can I simplify? 125, which is the same as 0.16. Okay, so this one is the helix, right? So we talked before. Conclusion, the curvature of this helix is a constant. We get the number, right? So constant at all points on the helix, because we did not substitute 3 pi over 4 pi over 3, right? Well, we get just a number, so it's a constant. Make sense? So everywhere, right? So 0.16. Makes sense because helix, the figure is like that, right? Yeah. The sharpness is the same everywhere. Yeah. Okay. Now we have another example. So let's do it. Okay, so find the curvature of this function when x equal to 2. So let me show you a picture later. And then let's find out. So we have the formula number 3. Yeah, so let's using that. So we know how to apply every formula, right? So this one. So we have an absolute value because we have a y, right? Okay, so that. So let's say using y equal to square root of 4x minus x squared. Okay, then y prime, we want the derivative. So let's say using this is 1/2 power, right? Then drop the power, reduce by 1, so negative 1/2. And then chain rule. So inside, what's the derivative? 4 minus 2x. Yeah. Okay. Let's just simplify. So we have 2, 2, 1. So we will get, let's using 2 minus x in front. And then there will be 4x minus x squared, negative 1/2. Yeah. Yeah, I arrange it this way because we need to do second derivative of y, right? So what's the y prime? Second prime, sorry, y second prime. Okay. Product rule, right? So we're using f, g. So we want to derivative. Then f prime g plus f g prime, right? Okay. F prime, we get negative 1. G plus F, G prime, so we drop the power, and 4x. Oh, I need a space. So 4x minus x squared and negative 2. So 3, negative 3 over 2 and chain rule 4 minus 2x again, right? Okay, then we simplify again. 2, 2, 1, right? Okay, so that will be negative 1 over 4x minus x squared, 1/2. Yeah, bring down the power plus, and then we have 2 minus x twice. Yeah. Oh, there's negative 2, huh? Negative, missing negative. Yeah. Is there any negative again? So we have negative, yeah. So there will be negative. And then 4x minus x squared and 3 over 2. Okay, let's make a common denominator. So common denominator. let's make a CD. So that will be 4x minus x squared, 3 over 2, right? Okay, then we need 2 over 2 for the power, right? So that is 4x minus x squared, 4x minus x squared, right? Okay, so that would be negative 4x minus x squared minus, oh, this is squared, right? So hold on. So we have, note, 2 minus x to the quantity square. So 2 squared 4 minus 2 times a times b. So 4x plus x squared, right? Okay, but we have a negative. So 4 positive 4x negative x squared. Yeah. Okay. Then we have simplify. Oh, okay. I did not distribute, right? So it must be positive. Yeah. Then we can simplify. Huh. We have just a negative for that? Yeah. So we have negative 4 over 4x minus x squared to the 3 over 2 power. Okay, so this is just y second prime. So we have to have the absolute value. So negative 4 over 4x minus x squared to the 3 over 2 power, which is just positive. Right? Okay. Now, since we split numerator, let's do denominator. So, did I say numerator? We needed the denominator, right? Copy. So, denominator. Okay, so, oh, fly. Y prime. So we have y prime. Okay. So this is y prime. Okay, so that will be equal to 1 plus square there. So 2 minus x and 4x minus x squared, negative 1/2, then squared, right? So we don't forget we have a square. And then another bracket. Too many bracket to the 3 over 2. Yeah. Okay, so we have the power, -1/2 times 2. Then we get -1, isn't it? Okay, let me see. Okay, so we have different power. So this is the only this power, right? And this one does not have a power. So let's apply this one with that, this one with this. Yes? Okay, so there will be I don't know, too colorful, right? So 1 plus, so 2 minus x squared and 4x minus x squared. That's -1 to the 3/2. So that will be 1 plus 2 minus x squared over 4x minus x squared. And then -1 power bring down, just +1, right? And 3/2. Okay, now let's make a common denominator. So there will be 4x minus x squared and plus, extend. So 2 squared 4 minus 2 times 4x plus x squared. So 3/2. Simplify. Okay. I think we did that earlier, right? So 4x, x squared. So we have a 4 over 4x minus x squared to the 3/2, right? Okay. So let's bring up everything. So too messy. Copy. Too colorful, so I should change that. Y second prime, so we have that. Copy. Over the denominator, we get that, right? Huh. Copy that. Okay, so let's simplify. So we get 4 over 4x minus x squared, 3/2. And then there is 4x minus x squared, 3/2 over 4 to the 3/2, right? Okay, so we can simplify this one. So we have 4 over 4, 3/2. Note 4 to the 3/2 means the denominator of fraction is root. So square root of 4 to the third power, which is 2 to the 3, which is 8, right? So we have 4/8, which is 1/2. Yeah. Oh. What is this? Let me show you the picture. So the picture is a semicircle, right? So we can see that the radius equal to 2, right? Okay, then we learn the curvature of a circle is 1 over the radius, right? So we can see the 1 over 2. That's why I did not show you the picture earlier. Okay, so let me write down the curvature of this semicircle is equal to the reciprocal of its radius. So r equal to 2, so the curvature equal to 1/2. Yeah. Okay, so we have new terminology. One is normal vector. No, we learned that normal vector, right? And then binormal vectors here. So we knew the normal vector is orthogonal to other vector, right? So we have unit tangent vector here. So normal vector is orthogonal to unit tangent vector. Since normal vector is orthogonal to unit tangent vector, also unit tangent vector is orthogonal to normal vector, right? Okay, then we have binormal vectors here. Then this vector is orthogonal to unit tangent vector, also normal vector. And then binormal vector is always a unit vector, means that the has magnitude which is equal to 1, same direction of the vector, right? Okay, so we have normal and binormal vectors. So there's a formula. How do you find unit normal vector? Then same as this, right? So think unit vector u, then vector v of t over magnitude of vector v, right? Then unit tangent vector, there we go. There we go. There we go. So unit tangent vector, we did that. So r prime of t over magnitude of r prime of t, right? We are following same format. Yeah. Okay. Now, unit normal vector then t prime of t over magnitude of t prime of t. Yeah. Make sense? So unit tangent vector r prime of t over magnitude of r prime of t. Then we have a unit tangent vector, right? Then normal vector will be t prime of t over magnitude of the unit tangent vector. Yeah? Okay. Now, binormal vector, how do we find? We have to have a cross product of unit tangent vector and normal vector. So I talked about this one, and also I talked. All right. Now, unit tangent vector, normal vectors are unit vectors because the title said that, right? The name is unit tangent vector. The name is unit normal vector. So they are both over are unit vectors, right? So note, there must be 3 components to have binormal vector. Why? Because cross product, right? So cross product, if we have only 2 by 2, we cannot make a cross product operation. So must be at least 3 by, no, not at least. We learn only 3, right? Cross product. Yes? So we have to have a 3 component. Okay, so find the principal unit normal vector. If possible, find the binormal vector. So number 1, no binormal vectors. Why? Because only 2 components, right? Since there are only 2 components, must have 3 components to use cross product. Okay, now we have a second problem. We want to find normal vector and the binormal vector, right? Okay, in order to find the binormal vector, we have to have a unit tangent vector and unit normal vector, right? Okay, let's find out. But then if we don't have t equal to 0, it will be very messy and very long algebraic work. But we have a t equal to 0, so we can substitute easily. All right, so let's do it. So tangent vector first. Copy. So r prime of t, so -5 sine 3t and times 3, right? Times 3. And 15 cosine 3t and 5. Yeah. Over square root of -15 sine 3t squared. How about let's substitute 0, right? Squared plus 15 cosine 3 0 squared plus 5 squared, right? Okay. Let's just substitute when t equal to 0. So we have -15 sine 0 and 15 cosine 0, 5 over, okay. The first term is 0, right? And 15 squared, what did we have earlier? 15 squared? 225, right? So 225. And then that is the one, right? So 225 plus 5 squared, which is 25. So the denominator has 250. Okay. So we will get the first term is 0, 250. So square root of 250, 15.81. So let's make it just a 0, 15 over square root of 250, and 5 over square root of 250. Yeah. So when t equal to 0. Yeah. Much easier. Yeah. Otherwise, oh, too crazy. Okay. Now, you need normal vector. So you need normal vector. Copy. Okay, so we have let's using t. So t will be about negative 15 sine 3t and 15 cosine 3t and 5. Oh, that's the t, right? So 1 over square root of 250. Yeah. Okay, so t prime over t about okay. So we get negative 15 over square root of 250 and cosine 3t times 3, right? And 15 times 3, 45, negative 45 over square root of 250 cosine 3t, yeah, and then 0 over, let's say using t equal to 0, right? So that will be, oh, I made a mistake. So derivative of cosine is a sine. And then I put the negative, right? That is correct. So sine. Okay, so that will be negative 45 over square root of 250. Cosine 0 is 1, right? And second one is 0. When t equal to 0, plus 0. Nice. So this, okay. The denominator has 45 squared, right? So 45 squared, which is 2020, I mean 2025. Okay, so we have 1 over Can you simplify? 2025 over 250. Yeah. Um, let me calculate. Oh, we don't have to calculate, right? So just itself. Just itself means it's a 45 over square root of 250, right? Same as. And then we get negative 45 over square root of 250 cosine 3t and negative 45 over square root of 250 sine 3t is 0. Okay, so when n equal to, t equal to 0, so this is 1, right? So we get 1. So we get cosine 0 and sine 0 and 0. Yeah. So we get 1, 0, 0. Yeah. Okay. Binormal. So binormal, which is cross product of unit tangent vector and normal vector. Yeah. This is the last one. Hang in there. Okay. So tangent vector, we get that, right? Okay. And normal vector. So let's just using that. Is it tangent vector? We don't have that. Okay, so I want to use when t equal to 0. It's a more easier way calculate, right? So this is a normal vector. Okay, what if we have a 0? So we have 0 there. 15 over square root of 250 and 5 over square root of 250. Yeah. Okay, so cross product. Copy. I, J, K. Unit tangent vector 0, 15 over square root of 250. 5 over square root of 250. 1, 0, 0. I, J, K, I 15 over square root of 250, 5 over square root of 250, 0, 0, and J 0, 15 over square root of 250, 1, 0, K 0, 15 over square root of 250, 1, 0, right? 0, I, and 0 minus 15 over square root of 250 and plus 0 minus 15 over square root of 250. Okay. Did I copy wrong? Oh, yes. No, K. Hold on 1 second. Let me double check. Yeah, J has the problem, right? So J, hiding J, so should be 5. So 5 there. 5. Yeah. So it should be 5. And this is a 15, right? Okay. So we get 0i plus 5 over square root of 250j minus 15 over square root of 250k. All right. So if I made a mistake, please let me know. Yeah, I need your help. Okay, so we done for this section. Thank you for watching. I will see you in the next section. Thank you. Bye.